an electronic device. Along with that, it is an electric device also. What do you mean by non-positional and positional number system? The value of each digit is determined by the digit itself. Decimal number system usually will have 10 symbols or digits. Hello students, welcome to the next session of the digital electronics. Myself, Dr. Soumyashree, Department of Computer Science, Vidhyaashram College. In the last session, the topic was about the introduction of digital electronics. Like, what is digital electronics? What are the concepts that can be studied, and why do we need those concepts and other main things. In today's session, we'll be discussing about next concept in the digital electronics, that is of number system. Okay, so number system, we know about number, isn't it? We have used the numbers from our childhood, maybe from 3rd year of our life or 4th year, we started studying about numbers. What's there in that? What's new in studying number system again in undergraduation level? Because as we have said in the last session, the computer understands only numbers. That is, only two numbers, 0 and 1. And why is that? Is because computer is an electronic device. Along with that, it is an electric device also. Electrical device means it runs on the current or electricity. So electricity has only two states. What you can do with the electricity is either you can switch on or you can switch off. For these two states, that means computer recognizes the changes only when there is change in the or there is fluctuation in the electric signal passing to it. Otherwise, it won't understand anything. Even it won't understand the numbers. It understands only the fluctuation in the electric signals. And what are the fluctuation that can happen in electric signal is either it can go to low state or off state, or it can go to high state or on state. As we said in the last session, the low state or off position, off condition will be represented as 0, and on condition will be represented as 1 or high state. Using only 0 and 1, we have to do everything within a computer or an electronic device. What happens if we use those two numbers? Is it possible for us to understand every operation in computer using only two states? If it changes from 0 to 1, 1 to 0, there will be a change in the operation of the computer. But for us, for human beings, it is not able to follow this operation of computers using only two values. We cannot cope up with only two numbers. For certain basic operations, we can handle with only two numbers. But as the number of calculation increases, it will be very much difficult for us to understand. If you click on a mouse or if you click on a keyboard, it will be handling as there will be fluctuation in electric signal passing through the keyboard to the processor. But in that way, if I press a character A from my keyboard, that A will cause change in the electric signal which will be passed to the processor. What must happen? That A must be printed back in the monitor, one of the output device. If the computer prints the output as it is given in the processor, as it is processed in the processor, we will not be able to recognize that because it handles A as numbers only. For us, it is character A, but for computer, it is again a number only. If it is displaying the value or displaying the character A as it is processed by the CPU, we human beings will not be able to understand it. If I send A as it is to the processor and if it doesn't process, it will not be able to understand that I have typed character A in my keyboard. What is the solution then? For this, we have the conversion between systems because, for example, if I know one language and your language is different, suppose I am talking in English or Kannada or whatever language and your language is different. You are from France or Spain, you will not be able to understand, or Japan, you will not be able to understand my language. If I am talking in Kannada or Hindi, they will not be able to follow my language, is it not? If they are talking Japanese language, I will not be able to understand what they are saying. What is the solution for this is, we will be having a person who translates language. He will translate Japanese language to Hindi or Kannada or whatever language I understand, and in turn, what I have said will be converted to Japanese or whatever language the opposite person understands. So this is where we are choosing the conversion between the languages. Now, the same thing happens between us and the computer. What I am saying must be understood by the computer, and what the computer has processed must be understood by me. For this, one language or one system will not work. What we have to do then? One thing what we can do is, we can convert according to the receiver who receives that data. If I am the sender, I will send A, which will be converted to the language which could be understood by the computer. And the computer processes that value and converts back to the system that I can understand. Like A will be converted to numbers in the CPU, and when it comes to monitor for one of the output device, it will be displayed as A, for which I am comfortable. I am comfortable with A. I can understand A. So, it converts the number to A and displays it on the output device keyboard, or maybe for the printer, any output device. So, main thing is, we have to do the conversion between the numbers. What are the different number systems that are present? The usual or familiar number system that we use is, what are the basic numbers you use is 1 to 10, is it not? 1, 2, 3, 4 up to 10. The normal number system that we generally use in our day-to-day life or in mathematics or general subjects is called as the decimal system. Why it is called as decimal system is, the term decimal represents a value. So that value will be used to represent the numbers. So these things will be discussed in today's session. First, we have the number system or the numeral system for representing the numbers. As it is said, number system is used to represent the numbers. These numbers has two types. There are two types of numbers. One is the non-positional number or non-positional number system. The number system is broadly categorized into two types. One is non-positional number system and second one is the positional number system. We didn't know about this, is it not? Or we have forgotten what we have studied in primary classes. Is it not? Elementary classes. Now we shall just recap or revise what we have forgotten long back. Okay. Non-positional number system and the positional number system. What are the numbers that are in non-positional? What do you mean by non-positional and positional number system? That we shall be looking at now. First one is the non-positional number system. What does the non-positional number system will suggest is, it uses the symbols instead of numbers. Such as first for 1, second for 2, third. This is what called as Roman number system, is it not? So this is a non-positional number system where we use different numbers, different symbols for representing a number. If you want to represent 10, how do you represent it? With the help of X, is it not? If it is 9, 8 or 5, 20, like this, is it not? We are familiar with this. This number system is called as the non-positional number system. Why is that it is called as non-positional number system? What is the speciality of this? Why it is recognized as non-positional number system is, each symbol represents the same value. Wherever you put it, it represents the same value regardless of its position. That means wherever it go, it remains 5 only. This 5 remains 5 in whatever position you place it. Is it not? What is the position? Why do we need this position? We shall look at it now. Before that, we shall complete the non-positional number system. These symbols are added to find out the value of a particular number. Position doesn't matter here. Position of the symbol, wherever you put it, it remains the same. The value remains the same. And these symbols are added to get a new number, or added or multiplied, whatever it is. Basic operations will be done on these symbols. It doesn't have value based on the position. Wherever you put, it remains the same. Wherever you put it, it remains 10 only. Okay. This is about non-positional number system. But it is very much rarely used because there is a difficulty in using this number system, because it is difficult to perform arithmetic operations with this number system. You can do basic operations like maybe addition, subtraction, multiplication or division. But it is difficult when you go for higher mathematical operations and is even not suitable for performing in computers. Because of that, non-positional number system has very much less application in the real world. It is used only to represent something like a list or something. For that we use non-positional number system or Roman number system. Then what is the number system that we use most widely used is the positional number system. Next is the positional number system. What does this happens, or what does this signifies is, uses only a few symbols called as the digits. In positional number system, the symbols, here also we use the symbols, but they are called as the digits, which can be counted. As I've said in the last session, digit stands for finger. So this digit can be counted with ease compared to non-positional number system. And the thing in positional number system is it represents different values depending on the position they occupy in the number. If you have a number, based on position, on which position that particular digit is there, its value changes. Getting confused? Not understood? We shall give you an example for this. Suppose you know about the number positions, isn't it? Like unit position, 10th position, 100th position, 1000th position, 10,000 position, lakh, 10 lakh, like this. You are familiar with this system, is it not? The basic number that we have read is of same thing, is it not? First is the unit value, 10th value, 100th value, 1000th value, 10,000th value, lakh value, 10 lakh value, crore, 10 crore, like this, is it not? So this is the position. What I have said is position based on which the value of the digit changes. How does the value of the digit changes? Suppose I'll take an example of 5. 5 is a number or a symbol or can be called as a digit. What does the positional number system says? The value changes depending on the position. How does it changes? Suppose if I keep 5 in the unit position, what is its value? It is 5 only. There is no change in the value. Suppose if I move the 5 to this position, the remaining positions will be filled with 0. Now, same 5, if I move to the 10th position, now what is the value of 5 becomes? It becomes 50, is it not? If I move 5 to the 100th position, what happens now? It becomes 500, is it not? In the same way, if I go for 1000th position, if I keep the same digit 5 in the 1000th position, what it will become? It will become 5000, is it not? If I move to the 10,000th position, what happens? Changes to the 50,000. Now its value is 50,000. The number is same. What is the number? The number is same, 5. Or the digit that we have used is same, 5. But based on the position, its value changes. Is it not? 5, 50, 500, 5,000, 50,000. If I go to lakh, it will become 5 lakh. Is it not? So, because of this change in the value based on the position of the digit, it is called as the positional number system. This is the number system that we are widely using, is it not? Whatever you count or something, what you do, numbering, calculations, whatever it is, what we use is this positional number system where digit value changes with the position. You now understood what is the explanation of this? Changes the value based on the position. So this is about positional number system. We have broad division of non-positional and positional number system. Okay. In non-positional number system, we don't have much choice. we have only one Roman number system. But in positional number system, in this, the value of each digit is determined by the digit itself. Whatever we use, the digit has some value, but its value changes with the position. The position of the digit of the number, that is value of each digit by digit as well as position. And the base of the number system. If you are using some other number system in positional, based on the base, the value changes. What base you are using? Based on that, the value changes. What is this base? That we'll discuss now. Base is total number of digits in the number system. What are the total number of digits in the number system that we use? We have, if you want to count the basic numbers that we use, it starts with not 1, it starts with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are there? Total number of digits in the number system. 0, 1, 2, 3, 4. In total, we have 10 numbers. Total 10 numbers we have in this system. The system that we usually use, is it not? So this is called as the base. Total number of represents a base. 10. 10 represents a value or 10 represents a word. So this is a system where 10 numbers are used or 10 digits are used. The maximum value of a single digit is always equal to 1 less than the value of the base. What will be the base? If this is base, this is represented as R. Usually, base will be represented as R or radical. One of the system that we use usually is having 10 numbers. So it is called as the 10. Maximum value will be 1 less than 10. That is 9. Count starts with 0. 0 to 9, 10 numbers. That means total number of maximum value of a digit will be 1 less than the 10. Other examples we'll be looking now. One of the example is, if it is 10, maximum value or of the single digit is 9. What is the maximum value for other systems? Now we shall look at what are the other systems that is available. The system where we use 0 to 9, 10 numbers is called as decimal system or is called as the decimal number system. Decimal number system. We have decimal number system. Apart from decimal number system, we have the octal number system, hexadecimal number system, and the binary number system. Okay. Mainly, we are going to study 4 types of positional number system, that is decimal, octal, hexadecimal, and binary. What is the value and how does they differ from each other will be the next thing that we are going to learn. First is the decimal number system. Decimal number system, as I have already said, it is a positional number system. So, positional number system is where position adds the value to a digit, is it not? So, this decimal number system usually will have 10 symbols or digits. As I have said, 10 symbols or digits. The term decimal refers to 10. Okay. How many digits are there is? From 0 to 9. Since there are 10 numbers, it has its base as 10. So base is 10. Digits are 10. Maximum value is 9. So maximum value of a single digit is 9, which is 1 less than the base. Each position of a digit represents specific power of the base. What that will be now we shall discussing. Power of the base. How do we represent the power of the base is a different thing. So each position of a digit represents the power of the base. Okay. Now we shall look at an example representation. Here I have a number 2586. Numbers with 4 digits 2586. How do you read this number? 2586. Is it not? That I have represented here. Like if it is in column wise, you can represent 2586. This is how you are going to represent in your basic maths class. Is it not? If it is, if you say it is, you will not pronounce it as 2586. This is year 2020. Will not pronounce it as 2020. Present it as 2020. Is it not? Why it is? Because the number digit 2 is in the 1000th position. So it is 2000. The number 5 is in 100th position. So it is 500. The number 8, digit 8 is in 10th position. So it is 80. 8 into 10. 80. And 6 in the unit position. So it remains as it is. 2. If I take 6 here, what happens? Instead of 2, if I use 6, it will become, and if you change the 6 value to 2, it will become 6582. Digits are same. If the value of 6, position of 6 changes from unit to 1000, it will become 6000. Previously, 2 was in 1000 position, so it was 2000. When it comes to unit position, it will become 2 only. So the number will become 6582. So this can be reduced like this. 2000 can be represented as 2 into 1000, 5 into 100, 5 into 100, 8 into 10, 6 into 1 based on the position value 1000, 100, 10 and 1. We can again further, you can make the short form like, you can represent like 2 into 10 into 10 into 10 as the base of 10. We have to represent it as a base of 10. So 1000 can be represented as 10 into 10 into 10. Is it not? 2 into 10 into 10 into 10. Same 1000 will be represented as 10 into 10 into 10. What happens to 500 or 5 into 100? 5 into 10 into 10. Now 8 into 10. So 10th position 8 into 10. Now 6 into 10 or unit position 1 it is. Is it not? Now further you can make it reduce like this instead of 10 into 10 into 10, we can represent as power of 10. That is what said in the previous slide. We'll be representing these 10 into 10 into 10 into power of 10. That is 10 to the power of 3. Will represent 1000 only. Is it not? Next comes is the 5 into 10 into 10. This can be represented as 10 to the power of 2. Then 8 into 10 to the power of 1. Is it not? Next, 6 into 10 to the power of 0. Any number to the power of 0 represents 1 only. Is it not? Anything to the power of 0 will be 1. Is it not? So it is 10 to the power of 0. How you can represent is 6 into 10 to the power of 0 plus 8 into 10 to the power of 1 plus 5 into 10 to the power of 2 and 2 into 10 to the power of 3. If you have another number, it will become 10 to the power of 4 for 10,000. Is it not? So, we can represent the numbers in decimal number system with the base 10. Now, this is the base. 10 is the base. Now, we have reduced it to the base to the power. Base to the power. That is 10. It is the base to the power of 0. Base to the power of 1. Base to the power of 2. And base to the power of 3. It goes on continuous like this. Now, this is octal number system. Before that, if you look at some other example, 2, 5, 9, 7, 1. If this is the number, how we can represent is 2 into 10 to the power of 0, 1, 2, 3, 4. So, it starts with to the power of 0. Is it not? 2 into 10 to the power of 0, 1, 2, 3, 4 to the power of 4 plus 5 into 10 to the power of what? 3 plus 9 into 10 to the power of 2 plus 7 into 10 to the power of 1 plus 1 into 10 to the power of 0. So, you can represent this number in 10 base like this. You can try with other numbers, or you can try with multiplying this or completing this calculation. You will get the same value. You can counter check the representation. So, the number 25,971 can be represented like this. Okay. Are you clear with this? Now, next is the octal number system. The term octal represents the value 8. It represents the value 8. It is again a positional number system. In this, the base is 8. What does the rule in positional number system says? The maximum value must be 1 less than base. That means maximum value that you can use in this system is 7. 0 to 7. You can use 7 numbers. Maximum value of octal number system is 7 and its base representation is 8. Okay. Each position of a digit represents a specific power of the base 8. Now it is not 10 because 10 is in decimal number system. When the number system changes to octal, it will be using the base 8 and power of 8 will be used to represent a number in octal system. If you look at the example, we have an example here, 2057. So this will be represented as base. Base will be represented as like this, as a base. Okay, if it is 10, it will be 2057 to the base 10. A representation we don't use the term base, but it will be there that every number will have a base. 10 will be omitted because it is the normal number system that we use. So we have just omitted using the number 10. Here, to differentiate the numbers with different number systems, we have to specify the base of the number. So here it is 2057 with the base 8. If it is octal number system, we use 8 instead of 10. Same, first will be 8 to the power of 0 represents 1, 8 to the power of 1, 8, 8 to the power of 2 and 8 to the power of 3. In the power, it will be represented. Okay, maximum value you can have is 7. 2057 you can represent. You can't use the value 2078 or 8951. This cannot be of number system octal because it has exceeded the maximum value of octal number system. This one. This can be an octal number system. This can be represented in octal number system. This can be represented in octal number system. But value next to 7 cannot be entering or cannot be represented in octal number system. So this is octal number system where each position will be represented as power of base 8. This is the base. So this base to the power will be used to represent a number in the octal system. This is the representation. Suppose if I have 3, 5, 1, 4, 6 to the base 8, this can be represented as 3 into 8 to the power of 0, 1, 2, 3, 4. 4 plus 5 into 8 to the power of 3 because 8 is the base plus 1 into 8 to the power of 2 plus 4 into 8 to the power of 1 plus 6 into 8 to the power of 0. So we use power of 8 in octal number system. Okay, now we shall move on to the next system, that is hexadecimal number system. So this hexadecimal number system represents the value 16, hexadecimal, decimal plus 6. Hexa represents 6, hexadecimal, decimal is 10, hexa is 6, that is 16. Okay, in this 16-digit number system, the maximum value is 0 to 15, 1 less than 16. Along with this, we have the numbers which have 2 digits, 10, 11, 12, 13, 14 and 15. In this, there will be a confusion if I use the number 2, 1, 4, 5, 8. If I use this number, what happens? There will be a confusion that whether this is number 14 or digit 1, 4. So there will be a confusion because these numbers represent 2 digits. To avoid this inconvenience, confusion, the numbers where 2 digits are occurring will be represented using the English alphabets. Like for 10, A will be used, B will be representing 11, C will be representing 12, D will be representing 13, E will be representing 14 and F will be representing 15. Suppose if this is the number and 14 is number, it is not 1, 4. If it is 14, you can represent like this 2, E, 5, 8. So you have to represent this 14 like this. Instead of 2-digit number, we represent it as one of the English alphabet E. We have to remember this throughout our subject. Whenever there is hexadecimal number system, there may be occurrence of the alphabets A to F. Okay. So maximum value of a single digit will be 15. It cannot exceed 15 or F. Each position represents the specific power of base 16. Since it is hexadecimal, we use the base 16. The example will be shown here. Here we have represented 1AF to the base 16. How do you represent it? 1 into 16 to the power. It was 10 to the power. Octal was 8 to the power. Hexadecimal is 16 to the power. 16 to the power 2. Next, A into 16 to the power of 1. Then F into 16 to the power of 0. For calculation purpose, for representation, we can use the alphabets A and F. But for calculation purpose, we have to use the representation of A. A will be represented for 10. A representing 10. So 10 will be used for calculation. Whereas F is representing 15. So 15 will be represented for the calculation purpose. For making it ease or for removing the confusion of double digits, the English alphabets are used just for representation. For calculation purpose, you have to convert that alphabet to the corresponding number. A, B, A to F, that is 10 to 15. Okay. So this is about the number system, that is decimal, hexadecimal and the octal number system. So comparison of these three systems will be given in the end. The main system that we have to use throughout our subject is one, that is binary number system. As I have said in the last session, the term binary represents two values. So only two values, where it is a positional number system. Again, the value changes with the position. It uses only 2 digits. As it said, binary is 2. Only 2 value, like we use Boolean values, true and false values. Like that, we have only 2 digits, 0 and 1. Okay. Since they use only 2 digits, the base we use is 2. The maximum value that we can have is 1. It can be either 0 or 1. Maximum value you can have is 1. Because 1 is because it is less than 2. So we have only 2 values, 0 and 1. Okay, each position represents a specific power of the base 2. Again, we represent these numbers in power of 2. So, this number system is the most widely used or general used number system in your electronic devices. Not only computers, if you take any electronic device, processing will be done even though it represents the numbers in decimal system. The processing will be done in the binary number system. Why it is binary number system? That I have already explained, is it not? So, we have the binary number system with the base 2. Example of binary number system we have here. You can use only 1001, 1001, combination of only zeros and ones. So, along with that, we have base of 2. 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1 and 2 to the power of 0. Okay. So, we have these systems representing the base 2. These are the basic or widely used number system. What are they? Decimal, octal, hexadecimal and binary. Apart from this, you can use any base system. Suppose if you are using base as 4, the value you can have is 0, 1, 2, 3. Maximum value, can you represent like this? 2, 3, 1, 1 to the base 4 can be represented like this. 2 into 4 to the power of 3 plus 3 into 4 to the power of 2 plus 1 into 4 to the power of 1 plus 1 into 4 to the power of 0. So, base or radix, based on that, the maximum value, representation, all will differ. But these number systems that we don't usually use it, but you can, for general purpose, can have that any base system can be used for representing a number, but the maximum value will be 1 less than the base value and power of that base will be used to represent that number. Okay. Now, we have a tabulation of comparison of different number system, decimal, binary, octal as well as hexadecimal. Okay. Here we have the representation of all the number systems: decimal 0 to 9, binary 0 and 1, base is 2, decimal base is 10, octal base is 8, 0 to 7, hexadecimal base is 16. Numbers are 0 to 15, where 10 to 15 are represented using the English alphabets A to F. Okay. You have to remember these systems for throughout the subject. For all the purpose, all the calculations and other purpose, we use one or the other number system in our whole subject. So, remember these number systems, what are the base, what are the maximum values that can be used in this number system. In the next session, we will be discussing the conversion of a number from one system to another. Say from decimal to binary, or from binary to octal, or from hexadecimal to decimal, like this. We can interconvert the numbers from one system to another system. How do we do that will be the topic of next session. Thank you.